Good evening, everyone. Today we'll solve some couple of problems related to uh, power transformers as in line with your assignment 2. Okay, so you have the question for this as a three winding transformer is there. You have got 6 ampere flowing in the primary winding represented by this red color, and uh, secondary winding with blue color, and the green color represents the tertiary winding. We have got a 100 ohm resistive load terminated at the secondary winding and 50 ohm at the tertiary winding. Primary winding has 75 turns, secondary has 100 turns, and 75 turns are with the tertiary winding. You have to find out the RMS value of current in secondary winding. Please start attempting. Uh, I will give you around 2 minutes then before I start to solve. Fine? Is that fine?
Yes, sir.
Okay. I request everyone to stop me and ask wheresoever they are stuck. I will suggest you as a hint, you will use MMF balance equation. And since we have given it in the question, it is given that transformer is ideal. So for a case of ideal transformer, assuming that infinite permeability of the core, we will assume the magnetizing current to be zero. Okay, so that you can neglect a magnetizing current and apply MMF balance directly. So let me start. We have you have been given, this is, let's say this is I1, this is I2, this is I3. So this is N1 turns, this is N2 turn, and this is N3 turn. So how do you apply MMF balance? This is N1 I1, this is the source, is equals to N2 I2 plus N3 I3. Had this been a case of non-ideal transformer, you would include here N1 I0. And since it is ideal case, so we will neglect this part. Okay. So apply this. We have got N1 as 75, I1 is 6, we have N2 as 100, and N3 as 75, and I3 is unknown. So how do you find this further? We have got another relation. What is that relation? We have, let's say, voltage is V2 across this, voltage is V3 across the tertiary winding, and this is V1. So if I ask you uh, you are well aware of the relation that V1 ratio V2 ratio V3 will be in the ratio of 75 is to 100 is to 75. Also, if I ask is what is the value of V2, V2 that will be 100 I resistance into current 100 I2. Similarly, what will be the value of V3? V3 will be equal to 50 into I3. Clear? Clear or not?
Yes, sir.
Okay. So From here you have equation 1 equation, and from here V2 by V3 can be written as 100 upon 75 is equals to 100 I2 by 50 I3. From here you can write this as, this is 2, this is 3 by 4. So I3 is, I3 can be written as 2 into 3 by 4 I2. You have got one relation between I3 and I2. From here we will substitute in this equation. Then after substituting, this will be 75 into 6 is equals to 100 I2 plus 75.
I3 is equal to, sir, is coming now, sir.
What is answer?
3.164.
Okay, fine. What about I2?
Just okay, sir.
2.11.
2.11. Okay. You can solve this equation. You will get I2. I2 is equal to 2 point. What is the answer? 2.11. And I3 is something around between 3 point something.
3.164 ampere. Yes, sir.
16. And what about I2?
Just, sir, please wait. Into 75.
Now next part is estimate the value of supply voltage. What will be the value of supply voltage?
Supply voltage. Yes, sir. Uh, 3.164 into 50. 158.2 volts.
158.
2 volt.
For others, I'll tell you that from V2 will be equal to I2 into 100, and from you have relation between V1 by V2 as N1 by N2, and from here, since you know I2 value is 2.11, substitute here, you will get value of V2, and from there V1 will be equal to N1 by N2 into V2. Is that clear? Please respond.
Yes, sir.
Okay. Now, uh, next question is calculate the power delivered. Calculate the power delivered.
949.2 watts, sir.
That will be P source will be equal to V1 into I1, and this what value are you getting?
949.2.
Okay. Excuse me, others are solving or not?
Sir, I have a doubt
Yes,
in
please.
this power calculation.
Yes.
Sir, when we multiply V1 and I1,
Hmm.
do we get kilowatt or kilovolt ampere, KVA.
Okay.
Which one we will be getting?
Yes, listen. See, what is the case here? We have neglected we have assumed transformer to be ideal. Once we assume the transformer to be ideal, we are making the magnetizing current of the transformer to be zero. So in such a
Okay.
case, transformer, if you multiply V1 and I1, you are going to get the purely resistive loss, power loss, or purely real power you will get. Clear?
Okay.
Had there been had there been this case of non-ideal transformer, then you would get some no load current. Then if, if the secondary load would be other than R, it would be RL. Let's say this would be a combination of RL, so you would get some load current
Okay.
in the secondary. Then this would
Oh.
form your IA2. Then again there would be power factor would come in at the primary side. Okay,
Ah.
so
Ah.
since we have
Okay.
neglected this and assumed the resistive load being fed at the primary and the secondary and the tertiary winding, so
Yes, sir.
okay,
This is because due to only resistive load, na, sir.
this is the
Sir,
case. This is the case only with the resistive load. Had this case been other than resistive load, this would involve the uh,
power
we
factor.
yeah, yes, we would deal with terms of phasors, not with this.
So if it was a non-resistive load, the power delivered by the source will be V1 I1 into cos theta,
Yes, yes, yes,
where theta is the power factor angle.
yes, yes, yes.
Okay.
Okay, I will deal with one of the questions. Let me complete this so that you have a clear idea about how the power factor and all these things are working. Okay.
Yes, sir. Okay.
Now
Thank you, sir.
calculate the power that will be V1 into I1. Now next question is that you are getting answer as 948 watts. Please verify
Sir,
this.
I am getting 949.2.
Fine. This is a rough estimate. Actually, I have
Yes,
not
sir.
used calculator. Someone of you told, so I wrote this. And
Sir. Okay,
now,
okay.
now next question is calculate the impedance seen by the source. So impedance seen by the source. Your source is this. This is connected to the transformer, and it has been asked as seen by the terminals, what is the impedance? Again, Z has been asked. So you are knowing I1.
20, sir, 26.47.
Okay. Others, Z will be equal to V1 by I1, and that is coming out to be 158 by 6 ampere. That is approximately 26 point something approximately.
Yes, sir. 26.4705.
Okay.
Sir, I didn't understand this impedance calculation.
Yes.
Can you once more explain this impedance calculation?
Okay. See, it has been asked impedance seen by the source. So in such a case, what will you do? What is the
We will go for
source voltage
uh,
divided by the
uh,
current being fed by the source into the circuit will give you
uh,
impedance seen by the source. Clear?
yes,
That is V by
yes,
I. And since you are this is a case of resistive load at the secondary and the tertiary side, so we are simply getting V by I. Otherwise, we would be dealing in terms of phasors. Okay.
okay.
Okay. So now I will give you to deal with terms of phasor. Let us see one more question.
Sir, I have some query, sir.
Yes.
Sir, whenever I am doing the uh, assignment, sir,
Yes.
okay, then I got fraction numbers, okay,
Yes.
in decimal numbers.
Yes.
Then how much we should accurate, sir?
Right up to right up
After decimal up to which point, sir?
two decimal places. Let's say you have got 19.568 thing like that. So just
Yeah,
use rounding numbers and round up to two digits, two decimal places. This you can write as 9.57
sir.
like that.
Yeah, if I write 9.568, then
No,
there
no.
will be negative marking, sir.
Yes, there maybe it is not I don't know how the evaluation goes on in NPTEL, but best practice is to round up to two decimal places.
Sir, what if it was 19.55?
Fine, there enough range is given, so um, you just write up to two decimal places. Clear?
Okay, sir.
That is
It is your experience, sir.
19.555.
Yes.
If 19.555 came, what to do? How to round off?
Yes, yes. Round off. Use rounding. How to round? Please refer how to use rounding numbers and accordingly round off and answer. That's it. Any
Okay,
other
sir.
doubt?
Sir, just in previous in assignment question, I got a total power delivered by the source like 250.00348.
Oh, you are stuck with the same thing. I said up to do two decimal places. Don't you understand?
Then yes, sir.
Let me proceed.
Okay, thank you, sir.
Now we have another question based on three winding transformer only. Consider, please note the question. There is a three winding transformer. Just for the clarity of phasors, I am giving you this question. This is I1. We have a capacitor connected here. We have I1. This is the source. This is I2 given as 10 ampere. We have a capacitor. Current flowing here is 20 amps. Okay. Number of turns is 100. Here it is 160, and with the tertiary winding it is 60. So this is again the case of ideal transformer. So I am asking, calculate current in primary winding and its power factor. See, now I am asking, as some of you discussed right away, again I am giving a question like that so that you have some clarity uh, how to deal with resistive loads, oh sorry, complex loads. Are you all clear with phasors?
Yes, sir.
For resistive load, current will be in phase with the voltage. For capacitive load, the current will be leading by 90 degrees. So how would you do this? Again, N1 I1 is equals to N2 I2 plus N3 I3. Okay, so I1, see, since we are, the nature of primary current will be no more resistive, it will have some power factor. Let us see what will be the power factor at the primary side. So I1 will be 160 by 100. I2 will be 10 ampere, 10 at angle 0 degree, plus 60 upon 100 into 20 at an angle of 90 degrees. So please calculate this using phasors and complex calculation in using calculator. What are you getting I1?
Sixteen angle 0 degree with at it. Sorry, 12 angle 90 degree.
Yes, yes. Then add these two.
Yeah, 16.
What about others? Are you all getting?
I1 equal to 20 angle 36 degree.
What is the answer? What is the answer?
20 angle 36 degree.
20,
36.8 degree.
36.8 something it should come. This is simple. One current is here 16 and another current is 12. They are separated by 90 degree. So what will be the net current? That will be here, something like this. Total I1 will be this. This will be 16 square plus 12 square. This will give I1, and from here you can find out the value of angle phi. So I1 you are getting at 20. So PF will be, power factor of the source will be cos of 36.87, and that will be 0.8 leading. Okay. Now another question. We'll proceed with another question. We have a transformer. Fifty turns is connected to 50 hertz 220 volt RMS supply. Estimate the peak value of flux. Please calculate.
50x. How much the rated voltage, sir?
220 volt is the RMS supply, and a transformer coil is with 50 turns connected to 50 hertz. We have been asked what is the peak value of flux. So you have that formula, E RMS is equals to 4.44 F phi into number of turns. From here
0.019, sir.
0. Point,
019.
yes, right.
19.8 milliweber.
Yes, yes, right. So phi max is equals to 220 upon 4.44 into 50 into 50. So that is 19 point something, approximately 19 milliweber.
19.8. Yes.
Okay.
Sir, in this case, I have just taken a rounding figure, sir.
Okay.
Point after decimal four digits, sir.
I asked you to take up to 2 digits. That is fine. Clear?
Then in that case, a 19 milliweber will be only.
Okay. Try to include 2 decimal places along with. Okay. Answer will be
Yes, sir.
19.8 some 0 something, whatever answer is coming.
Okay, thank you, sir.
Hmm. Any problem? Anyone? Hello?
Yes, sir.
I'm asking to others.
No problem.
Okay. Should we proceed then? Okay. Now, please. Now, we have two transformers connected in a cascade manner back to end to end. So, it has been asked that two transformers are cascaded as shown in the figure. Ratings of each transformer have been given. Transformer 1 is having 100 by 1100 110 by 1100 volt. Another is 1000 volt by 100 volt. Both have same frequency, but they have different kVA ratings. One is having 2.7 kVA and another is having 3 kVA. So it has been asked how much is the maximum value of supply voltage that can be connected without exceeding the rating of any of the transformers. So how will we proceed in this question? See, you have got transformer 1. This is 110 volt. This is 1100 volt. kVA is 2.7. So next transformer is there. Next transformer we have 1000 by 100. Here we have 3 kVA. So what will be the primary current? I IP1. This will
Sir,
be,
V1 is equal to 100 volt maximum.
hold on, let me explain to others. So IP1 will be equal to 2700 divided by 100, and I secondary will be equal to 2700 divided by 1100. So Using a calculator, IP1 will be 2700 divided by 110, that is 24.54 ampere. Now secondary will be 2.45 ampere. Okay. Uh, in case of transformer 2, this is IP2, this is equal to this is equals to 3000 divided by this is equals to 3 ampere. For IS2 we have 30 amperes. Now since these transformers are connected, end to end, so winding of this transformer is designed for 2.45 ampere, and winding of this transformer can bear up to 3 amperes. So since these are connected here, so we cannot, this winding cannot carry 3 amperes. So we need to limit this current in the secondary winding up to 2 point, hello,
Yes, sir.
so we cannot exceed this value as 2 more than this value. Clear? So also the voltage of this winding, the insulation strength of this winding is designed as per 1000 volt. So we cannot impress this winding to 1100 volt. So we need to have, at the secondary we need to have not more than 1000 volt. If at the secondary we are having 1000 volt, so what is the turn ratio of transformer 1? Turn ratio A is
1/10.
okay, this is 10 or 1 by 10 if you take reverse. So if here it is 1000, so in that case it will, the maximum voltage which can be borne by the primary side is 100 volt. So answer is 100 volt. Maximum supply voltage can be 100 volt for safe operation. Now next part is, how much is the maximum value of supply current of supply current? Since in the current in the secondary side will be dictated as per the winding of the second transformer, which is, sorry, first transformer, because this is having 3 ampere rating and this transformer is having 2.45 ampere rating. So sorry, secondary of the first transformer is having 2.45 ampere. So if current is 2.45 ampere here, so what will be the current at the primary side of the first transformer?
24.5 amperes.
Okay, fine. 5. Okay. How much is the maximum value of kVA that can be transmitted to the load without exceeding the ratings of any transformer?
Two point four five kVA.
Hmm. What about others? I request others also to respond. So, what is the maximum kVA? What is the maximum kVA that can be transmitted to the load without exceeding the rating? That is, that is 2.45 kVA. Hmm. Next question is,
Sir,
suppose we have a hello.
sir,
Yes.
I have a doubt regarding the maximum current calculation in that question.
In which question?
Sir, when
In
this
question,
question, previous question.
maximum value of supply current.
Uh,
Okay.
Sir, when it is 24.5 ampere,
Yes.
then the value of voltage at that primary terminal will be 110 volt, no?
No, no. Yes, yes.
Uh,
No, no, no. It is
uh,
not like that. See, listen. How are we doing?
uh, uh,
Let me explain. We have this transformer. This is 110. Please, everyone, listen. This is by 1100, and this is 2.7 kVA. We found out the current in this winding can be 24.545 amps, and current here will be 2.45 amps. Now, in the second transformer, we have 1000 volt, and here is 100 volt. Now, since it is 3 kVA system, it will 30 amp, sorry, 3 ampere. Here it is 30 ampere. Try to understand. Since we are connecting these transformers, so this winding is designed to bear 1000 volts. So when we are connecting them in parallel, so this winding, since it is designed for 1100 volt, can bear up to 1000 volt also. Clear? Yes or no?
yes.
Okay. Now, when when we will when we will give when we will ensure 1000 volt across the secondary. That means by dividing by the turns ratio, you will get 100 volt maximum, which can be sustained by the primary side of the supply. Okay. Now,
Okay.
okay, now current current will be dictated by the current of the secondary of the first transformer. Since this can bear up to 3 amperes, but our this winding can bear not more than 2.45 amperes. So what will be the case here? We, in this entire circuit, 2.45 amps current can only flow. When we have 2.45 ampere current flowing in the secondary side, as per the transformation of current, we have I1 by I2 as N2 by N1. So I1 is I1 is unknown to you, I2 is known to be 2.45 amps, and N2 is N2 is 1100 1100 by 1100 by 110. So I1 in that case you will get 2.45 into 10, that is 2.24.5. You were saying that if we are getting 2.45 amperes at the primary, why not 110 volts? See,
Sir, 24.5 ampere at primary.
yes,
It is 24.5 ampere, not 2.45.
24.5 amperes.
Ah,
Yes, na? At
you said it wrong.
24.5 for safe operation, so that neither insulation breakdown is happening nor winding is getting overheated. So we will get 2.45 amperes flowing in the primary of the first transformer. For voltage will not be dictated by the current, that will be dictated by the voltage which can maximum voltage which we can apply, so that our uh, this transformer which is being cascaded can bear that same voltage. Clear?
Okay.
I mean to say, voltage at the secondary is decided at the maximum voltage which can be borne by the primary of the second transformer. We cannot apply 1100 volt to this transformer. So we have to apply 1000 volt. 1000 volt, when we will apply 1000 volt here, as per the transformation, we will get 100 volt at the primary, which is maximum allowable voltage. Suppose if you would apply 1100 volt, sorry, 110 volt here, 1100 volt would appear here, and since this winding can bear up to 1000 volt only, there may be insulation breakdown over the longer usage of this transformer. Clear?
Yes.
So we have
Yes.
100 volt at the primary.
Okay.
Now it is next question. Clear?
Okay, sir.
Okay. Now we have, suppose we have connected maximum allowable supply voltage. Question is, now 100 volt is connected at the primary of first transformer. Now under this condition, estimate minimum value of the load resistance can be connected without exceeding the rating of any transformer. Now we have when we have considered that all our uh, transformers are connected and supply voltages are uh, as per the ratings which can be withstood by both of the transformers. Now you have to calculate the value of load resistance that can be connected at the
Sir, please, yeah, exactly. Please, so, yes, sir. Please be on this
hmm.
stage.
We have asked maximum value of RL. We need to calculate RL.
4.08 ohm, sir.
4.08. What about others? Now, since we have said that 100 volt is here, as per the transformation ratio, 1000 will appear here. If 1000 is here, again we have a step down transformer of 100 by 10 times. This will again appear 100. Okay. Yes or no?
Yes, sir.
And here current is 2.45 amperes. So what will be the current here? 24 point
24.5.
24.5. So RL will be equal to 100 divided by 24.54 something. So in that case, what are you getting? What did you get?
4.08 ampere. Sorry, ohm.
Okay, 24 point. Okay, 4.08.
Ohm.
Clear to everyone?
Hmm. Sir,
Yes.
please go through my thoughts, sir. I am slightly in a dilemma, sir. Please note down, sir, on the screen. Just I'm saying what am I saying,
Yes.
sir. Please make a two winding of transformer, and if here is and if first winding has voltage rating of 100 volt, and secondary winding has a rating of 200 volt,
Yes.
and I have no idea about the which is which type of this transformer, either step up or a step down.
Yes.
And in question, they asked me that what about the transformation ratio? Then in which way I have to calculate?
Okay.
Mind
Now
you, sir, please. There is no information about the typing of the transformer.
see transformation ratio as per standards. If nothing is given in the question, you will write transformation ratio. If suppose in the figure itself it has been shown like this, that two winding transformer is there, here is 400 volt and here it is showing 200 volt, then transformation ratio A will be found out by dividing 400 by 200, that is equals to 2. Standard way of finding transformation ratio A is n high voltage turns by n low voltage turns. This is again 2. Clear?
Yes, sir. If
Suppose
there is,
suppose in the question they ask that the transformer is find out the transfer step down transformation ratio, then you would write 0.5 instead of 2. Clear? And suppose in the question it is given at a, let's say some transformer is there which is rated by 400 by 1100 something like
yeah,
that.
yeah.
Huh? So if you have to find out the turns ratio, you can simply make this diagram like this. Start with making the diagram, and this is 400, this is 1100, this is called as primary. When if it is written like this is primary and this is secondary, this is secondary winding. In that case, turns ratio, if they have asked the what is the turns ratio or what is the transformation ratio giving nothing, then write A or like that and write NHV by NLV is equals to 1100 by 400, that is equals to 11 by 4. And if not, if nothing is given, write like this. And if they mention, like when you will be solving problems, you have to refer refer the quantities to primary or to secondary. So wheresoever, suppose with this winding you have got source connected, you have got source connected here, and this is something 400 by 1100. So when you will, suppose this is r r1, this is r2, this is r2, and this is l1. So if I'll ask to simplify this circuit for calculation of power factor, anything, you will draw the equivalent circuit referred to primary in this case. Since supply is connected at the primary side, you will draw with respect to referred terms with respect to the low voltage side. So what you will do in that case, let's say for ease of calculation I am choosing this number as 800. So what will you do in this case? You will do simply, this is R1, this is L1, you will transform the refer the quantities towards the primary side. What you will do, this will be R2 dash, this will be L2 dash, value of R2 will be, R2 dash will be equal to, since I in the last lecture I told you that when we will refer to the lower side, the values will further reduce. That means R2 will be now equal to by A square. Okay. Now this A square will be 11 by 4. R2 will be A square. This is A is equals to 11 by 4. Clear? So always remember that whenever we are sending the,
Sir, that is true, sir,
yes,
because you have considered 400 upon 800.
yes.
That's why
So
there is the.
sorry. So now R2 dash, when this will come, will be referred to the secondary side, this has to reduce and this will become R2 by 4. Okay. L2 dash will become L2 by 4. Clear? So do not worry about this transformation ratio. This is not as complex as you are thinking. The people will, if the examiner's intention is to confuse in this, he will definitely ask you or ask in the question that uh, transformation ratio with respect to high voltage, low voltage, or step up, step down, and that you can easily make out seeing the question. Okay.
Okay, thank you, sir.
Okay. Hmm. Now next question we are having, Now we have a 30 hertz, sorry, a 30 kVA, 60 hertz transformer is used in a 50 hertz power system. If you remember in the last lecture, when on, I think so, on 29th or what's that, 30 or 1st of August, I had done one of this similar question. Under under this situation, what is the maximum kVA that this transformer can handle, so that no load current is not more than the rated no load current. Clear? So you have to a 30 kVA 60 hertz, the transformer is initially designed to operate at 60 hertz. Now we are operating this transformer in a 50 hertz system, and the condition is that you have to find out the maximum kVA this transformer can handle without exceeding no load current is not more than the rated no load current. What do you understand by this? No load current is not more than the rated no load current. Any one of you?
Yes, sir. Magnetizing current.
Yes.
That is. So we
The
have
climax.
the maximum value of kVA is 25 kVA.
Others?
Hello, sir.
Climax
I
should
ask
remain
Before
constant.
asking the answer, please explain what is the meaning of no load current is not more than the rated no load current.
Yes, sir.
hello.
Yes?
Sir, I ask you, no load current is not more than the rated current. Means, sir, transformer voltage is not exceeding, and its frequency is means voltage means flux density is always constant.
Yes, exactly. By this
And
this by including this statement, we are making that the transformer is operating at rated flux, is operating at, okay, we are not changing this rated flux. Now if that is the case, kVA is proportional to voltage, voltage is proportional to frequency. So when we had 30 kVA, the frequency was 60 hertz. Okay, sorry, when we were operating at 60 hertz, the kVA which was supported was rated kVA was 30 kVA. Now the transformer is operating at rated flux, but the frequency has come down to 50 hertz. So what will be the value of kVA? This will be 30 into 50 divided by 60. This is simply a unitary method now. If you are knowing the proportionality between the kVA and the frequency, so this is coming out to be 25 kVA. Clear?
Yes, sir.
Clear to all?
Sir,
Sir,
Yes.
sir, I am in a assignment two, sir. I have some dots, sir. Can you clear, sir,
This is
please?
assignment 1, na?
Yes, sir. This is the assignment one, and I have dots some assignment two.
Okay.
After
So,
the ending session, sir, can you explain? Can you suggest me, sir?
okay, you can please write the question in the chat box.
Okay, sir.
Okay. Mm. Now, next question. We have got a transformer which is uh, uh, which is fed by a source with some inductive load connected in between the primary of the transformer and the supply voltage. Now, this is the question. What is they have given that supply voltage is 400 RMS, transformation ratio N1 is to N2 is 50 by 100, and X is 240 ohm, RL load resistance is 400 ohm. Now you have to estimate the RMS value of primary current in I1. So, since nothing is given, we will treat this transformer this as ideal transformer. This is just going to, suppose this is V1, this is V2, this is going to just step up or step down the voltage between these terminals. Okay, clear? So they have given N1 is to N2 as, am I audible?
yes, sir.
Okay,
Yes.
so you can see this circuit in two parts. Let's suppose we have got V1 here appearing. This is Vs. This is Jx and this is I1. So apply KVL. You will write Vs in terms of phasor is J I1 x plus V1 to, in the secondary side we can see the secondary side we can see this as V2. This is feeding a load. This is I2. This is feeding a load 400. So what I will do, we can easily refer these quantities from this and from the secondary side to the primary side in this equation. So what will you do? This will be Jx1. This is 4. Sorry, this is Vs. And after referring this, what will be the value of RL? This will be
100 ohm, sir.
this will be RL dash is equals to RL divided by A square. What is value of A? A is equals to 100 upon 50, that is equals to 2. So RL was 400 ohm. It will be divided by 4, that is will become 100 ohm. Now this is 100 ohm. This is already given in the question as 240 ohm. They have asked primary current I1. What will be I1? I1 will be equal to Vs by Zs. What will be this? Zs will be 100 plus J 240. Vs is given in the question as 400 volt. So I1 will be equal to 400 angle 0. We'll assume V1 as base phasor, 400 by 100 plus J 240. So you can find this as 100 angle 0 upon, use complex calculation in your calculator. From there you will find 100 plus 240 J in polar form. It will be 260 at an angle 67.38. So what is I in this case? It will become
1.54.
100 divided by 260, that is 1.54 at an angle of minus 67.38. Since in the question it is asked only the RMS value, we'll write I1 mod is 1.54 ampere. Clear? Clear or not?
Okay, sir.
Okay. Now next part is estimate the RMS value of the secondary current. We have asked estimate the RMS value of secondary current. What you need to do? I2 will be, again we have a transformer in between, that is ideal in nature. Here we have N1 turns, that is equals to 50. Here we have N2 turns, that is equals to 100. Here current is flowing 1.54. They have asked what will be the current? I2. So yes,
30.8 ampere.
yes, anyone else? Okay, so I2 will be equal to, sorry, I1 by I2 is equals to N inverse ratio N2 by N1, that is 1.54 by I2 is equals to 100 by 50. So I2 is equals to 1.54 into 50 upon 100. What are you getting value of this? 1.54 divided by 2, that is 0.77. Clear? Clear to everyone? Yes or no?
Yes.
Yes, sir.
Okay. Now they have asked next part, estimate the power in watt supplied by the source. Please solve. Estimate the power supplied by the source. They have given this time. In the beginning you were asking, now we have this question. They have already mentioned that we need power in watt, that means real power supplied by the.
Sir, please scroll down the screen, sir. I want to see power factor. How much was the value of? Yes, sir. Please.
So if you are knowing that power will be equal to VI cos phi. So we have 400 I is 1.54 cos of 67.38. What is the answer coming?
236.924.
Hmm. We are getting 236.9244. Let's say I'm telling you how to see. Now it is, this answer is coming to 36.9244. Since this is not greater than 5, here also it is not greater than 5. I have asked you to round up to 2 digits, so you will write the answer as 236.92. Clear?
Yes, sir. Cleared, sir. Thank you, sir.
Okay. Suppose it was, suppose, suppose answer would be 236.9245 like this. Still, you would write 236.92 only. Suppose,
Sir, where you are writing, sir? I am not able to see her.
is the screen not visible to others? Is it visible right now? What
Yeah,
you are
yeah.
writing?
Now it is visible, sir. Okay, thank you, sir.
Yes.
Sup, suppose, suppose my answer would be 236.92925 something. Then I would round up by the rounding method, 236.93. Okay, if this uh, uh, after the second decimal place, if it is value is greater than equal to 5, then round up this value by one more. Okay, clear?
Yes, sir. Okay, thank you, sir.
Now we will take up some questions from last session which was left. Do you all know about the uh, efficiency calculations? Hmm?
Yes, sir.
We will solve a question related to efficiency. What is the transformer efficiency? That is VI cos phi, that is output power, VI cos phi plus PI, that is iron loss, plus this is PC, this is copper loss. And you know Needham efficiency max condition is that iron loss must be iron loss must be equal to copper loss for achieving maximum. Clear? Yes or no?
Yes, sir. Sir, in efficiency calculation, we take only a real power, sir.
Yes.
Why, sir?
Rest of the we consider that the reactive power is required to establish the magnetic domain, which is not taking trans. This magnetic domain is helping in the transfer of real power from one side to another side. Try understand. This is the transformer.
Sir,
If we
yeah.
neglect, if we neglect the leakage in leakage of the leakage flux which is arising from the primary or the secondary winding, then this the magnetic domain which is the magnetizing current which is establishing the flux is useful to transfer real power from this end to this end. Only resistive loss and this iron loss and this copper loss take part in the power loss, and we have the power from this end transferred to the secondary. Okay.
Yes.
Now we have efficiency, maximum efficiency uh, condition, that iron loss will be equal to the copper loss. So if I give you a question to find out what is the maximum efficiency, okay, note down the question. The maximum efficiency of a 500 kVA transformer 3300 oblique 500 volt 50 hertz single phase is 97% and occurs at 75% full load. 75% full load at unity power factor. If the impedance is 10%, calculate the voltage regulation. This has been covered in the lecture or not? In the video lecture, voltage regulation is covered or not? Hello? Anyone can
Yes.
respond.
Yes, sir.
Voltage regulation has been clear, covered in the ongoing video lectures.
Yes, sir.
Okay. At voltage regulation at full load, 0.8 power factor lagging. This is a very good question. They have given the maximum efficiency, of 500 kVA transformer is of the ratings of the transformer are 3300 by 500 50 hertz single phase is 97% and it occurs at 75% of the full load at unity power factor. If impedance is 10%, calculate the voltage regulation of regulation at full load 0.8 pf lagging. So how will you do? We have been given that maximum efficiency is equals to 97%. Can I write it 0.97? Okay. So when the next maximum efficiency is 0.97, we have given that formula for efficiency is Vi cos phi at the output upon Vi cos phi, and since this is neta max, we have Pi plus Pc, and where condition of under the condition of maximum efficiency we have Pi equal to Pc. So I can write as I can write max is equals to what is occurs at 75% of the full load. at unity power factor. That means cos phi is 1 and this is also 1. Huh? In so what I will write? 0.75, 75% upon 75%, 0.75 plus 2 pi. Okay, clear or not?
Sir,
Yes, please.
instead of VI, you are writing the value of. Yeah, sir, exact.
Since this is in form of percent, you can also write 0 point, since everything is given in terms of percent, but in percent we are going to relate this in terms of per unit values. You know, understand per unit values?
Yes, sir.
Okay. Hmm. So solve this. What are you getting? 0.97 is equals to 0.75 on 0.75 plus 2 pi. What is value of pi? What are you getting value of pi? Iron loss value.
0.54, sir. Upon 2. 0.27.
Sir,
0.27. No.
how is VI equal to 0.75?
0.
75. How it came 0.75 VI?
Okay, vi, how is it has come 0.75? See, full load transformer is having efficiency of rating of 500 kVA.
Okay.
So now when we are given in terms of 75% of the full load, that means 7 0.75 into 500 into at unity power factor. Unity power factor means cos phi is 1. So full load will become 0.75 into 500 into 1. And since all these values which are given in your question are in terms of per unit values, so I am leaving this in terms of per unit value only. Okay.
Okay.
Sir, please go through the per unit value, sir.
Yes.
Briefly, sir. Which will be
First tell me what is value of pi.
0.27, sir.
0.27. Let me see. Others?
आ, गलती हो गया.
This pi value will come 0.01159. Now we will consider, since we are having second digit also like that, so we'll round up to 2 3 decimal places. 0.0116. Since in you are dealing with per unit values, you need to consider up to 3 4 decimal places. Okay. Now you have got iron loss. You know, iron loss is fixed. You know, na? Iron loss is fixed. Why it is fixed? Because flux is rated flux. but copper loss is variable. Why variable? It it varies with load. Why load? Because the as you will change the load, the current value will change, and since copper loss is I square R, so I square will change, hence the copper loss will also be changing as the loading conditions change. So we said that Pi is equals to PCU at neta max, maximum efficiency. So but this this copper loss was evaluated at 75% of the loading. Now if I ask you to, now PCU at 0.75% loading is 0.0116 per unit. So if I ask you at PCU at 100%, how will you do? PCU is proportional to loading square. Do you know this or not? Anyone? Hello? Hello? Hello?
Yes, sir.
I am asking that do you know that copper loss is proportional to loading square? Yes or no?
No, sir. Please.
Okay. How it is proportional? I am telling you. What is PCU? Is I square into R. Yes or no?
Yeah.
R equivalent total resistance. Now, since we are operating this at the rated flux is at rated value, F at the rated frequency, so our voltage will be constant. Yes or no? So can I write this again is proportional to Vi? That means our copper loss is proportional to I square. Yes or no?
Yes, sir.
Can I write again this PCU is proportional to Vi square? If, as I told you, since flux is constant, since flux is constant or rated value, F is constant, we have not changed anything, it is not mentioned in the question that we are varying. So V is also constant. So PCU is this VIV is S proportional to S square, sorry. So now when PCU was at 0.75, it was this value. So if I ask you at 100%, you will write PCU at 0.75 upon 0.75 square, because it is proportional to S. So copper loss at PCU at 100% loading will become PCU, that is PCU at 75% is 0.0116 upon 0.75 square. What is value of this? What are you getting value of this?
0.0206.
0.0206. Now we have evaluated what is the copper loss at full load. Full load, full load copper loss we have got as 0.0206. Remember, this is very important expression, that copper loss is proportional to loading chi square. Copper loss is proportional to loading chi square, until unless they have given or manipulated in the question that frequency is changing or flux is changing or etc. So we have got copper loss at full load. Now they have given that impedance of the transformer. Impedance is 10%. 10% means Z per unit is equals to 0.01 per unit. Yes or no? Yes or no?
Yes, sir.
Okay. And in the question it is given that calculate the voltage regulation at full load 0.8 power factor lagging. 0.8 pf lagging. Voltage regulation is also function of your load power factor. You might have known this. Vr is equals
Yes,
to
sir.
R per unit cos phi plus X per unit sin phi. Yes or no?
Yes, sir.
R per unit you are knowing. R per unit, see, full load copper loss, full load copper loss, remember, full load copper loss is equals to per unit resistance of the transformer. How it is, I am explaining you. What did I say? Please hold on, we will come back to this again. I said that full load copper loss is equals to per unit equivalent resistance of transformer. How do we get it? We have if I ask you that what is value of R per unit, you will say R equivalent upon Z base. Per unit values are like, if I ask you V per unit, you will write, you will say V upon V base. Okay. Similarly, R per unit will be R equivalent by Z base. So R equivalent, can I write Z base as V rated upon I rated? Yes or no? Hello?
Yes, sir.
Okay. From here, R per unit is equals to R equivalent I rated upon V rated. Yes or no?
Yes, sir.
This R equivalent into I rated. What is this? This is
V rated.
full load. since rated value is there of current, so can I say this full load resistive drop? Can I say this or not?
Yes, sir, because maximum current is flowing.
So I can say it as a full load resistive drop, and this is divided by V rated. When anything is divided by V rated, this will become per unit. This will be called as full load resistive. Remember, this is full load resistive drop. I will tell you how it is equal to copper loss. Now, if I multiply R per unit is equals to R equivalent into I rated upon V rated. If I multiply rated current upon I rated, what will it become? This will become R equivalent into I rated square upon V rated into I rated is S rated. So R per unit becomes your, this is I square into R equivalent, it is equals to,
Full load copper loss.
yes, full load copper loss upon S rated. This will become, when you are dividing by, this is divided by S rated, this will become
Full
per
load
unit.
copper per unit.
Yes, exactly. Per unit full load copper loss.
Oh,
So R per unit, if somewhere you have got full load copper loss, in terms of per unit values, you can directly equate it equal to R per unit. If you find out per unit copper loss, then you can easily equate that equal to R per unit. So now I have proved that full load copper loss is equals to R per unit. Full load copper loss in per unit values is equals to R per unit. Clear? So now we'll go back to the question where I wrote that voltage regulation is R per unit cos phi plus X per unit sin phi. So now you got that R per unit, sorry, R per unit is at full load. Remember, this is 100%, is 0.0206. So voltage regulation, what will be the voltage regulation? X voltage regulation is equals to R per unit cos phi plus X per unit sin phi. Phi is given as, sorry, they have given that 0.8 pf lag. So cos phi is 0.8, then corresponding sin phi will become 0.6. If cos phi is 0.8, then corresponding sin phi will become 0.6. You can find out phi as equal to cos inverse 0.8, and then sin phi as sine of cos inverse 0.8. Okay. Now they had given that we are still not knowing x per unit, but we are knowing z per unit. Z per unit is given as 0.1. So x per unit will become under root of, sorry, you know na, z per unit is equals to r per unit square plus x per unit square under root. Yes. So from here you can find that x per unit is equals to 0.01, sorry, 0.1 square minus 0.0206 square under root. So what is the value of x per unit? Come on, fast.
0.098.
0.098 per unit. Is everyone getting? So what is voltage regulation? Is equals to 0.0206 into 0.8 plus 0.098 into 0.6. Solve this. What are you getting?
0.07525.
0.07528.
28
Okay, fine. So when you will, this is in terms of per unit.
per
So if I asked you in terms of percentage voltage regulation, you will multiply this by 100.
7.5%.
7.52%. That means when you will operate at full load condition, that suppose this is the secondary side, when you will operate suppose you are operating this transformer under full load condition, this 500 volt, which is full load voltage, will drop by 7.52%. Okay, clear? Is this question clear to you?
Yes, sir.
Okay, then thank you.